Hi, Advanced Algebra kids. Today we're going to be looking at day 3 of our statistics chapter. We're going to be focusing on the 5-number summary and then making box and whisker plots. So if we're looking at our 5-number summary, that's what we're going to look at first. So the 5 numbers that we care about the most when we're looking at the data is the min, the first quartile, the median, the third quartile, and the maximum number or maximum value in our data set. So the min number is just what it should be like. It's going to be our lowest number in our data set. And then we have Q1, which is going to be basically our median of the lower half of the data. Then we have the median, which is the exact middle number when we put them in order from least to greatest. Or it says if there's 2 numbers in the middle, you're going to have to find the average of those 2 numbers. For Q3, that's the third quartile. That's going to be the median of the upper half of the data. And then we have the maximum number, which would be the highest number in our data list. So we're going to start with that because that's our step 1. Step 1 of constructing a box and whisker plot is to put the numbers in order from least to greatest, and then to find those special 5 numbers. And we're going to take a look at example 1 first. All right, so for that first example, you already have all the numbers in order from least to greatest, and I just put them on little cards so that we can see what we're going to be doing. So first thing that you want to find is the median. So the median is the middle number, and in this data set, if you count them, like you can kind of look and see like where the middle should be, and there's one number that's clearly in the middle. So because there was an odd number, in this case, you had 2, 4, 6, 7 below and 7 above the number 18. The number 18 is in the middle, so that's our median, okay? Now we're going to look only at the lower half of the numbers. Is there a number that's clearly in the middle of those numbers? Well, again, you have an odd number of numbers. So out of those 7 numbers, the one that's in the middle of those would be our quartile 1. So our quartile 1 number is the middle or the median of just those lower half. Then if we look at the upper half of the numbers, we want to do the same thing. The number in the middle of those would be our third quartile or Q3. So that's the median of the lower numbers. And then you can recognize the min and the max. The min and the max would be the lowest and the highest of those numbers. Okay. So back on example 1, if we're looking again at those numbers and we want to say like which number's in the middle, we found that 18 was the median because there were exactly 7 numbers lower and 7 numbers higher than that with that sample set of 15 numbers. 7 below, 7 below, or 7 above, the 8th number is in the middle, right? So then we looked at the lower half and we said the middle of those numbers was this 10, that's Q1. The middle of the top half of the data was Q3 at 31. And then we said we had our min and our max. So on our 5-number summary, that's our first step, our min was 6, our Q1 was 10, our median is 18, Q3 is 31, and our max is at 104. Okay, the next step on our journey of box and whisker plots is we want to construct a box and whisker plot. So first we have to have a horizontal axis that spans the range from that max to the min. So, all right, so if we look at our scale, we're supposed to go from 6 to 104, but we want to count by something that's normal on this horizontal axis. So in order to go all the way from that large of a range, I'm probably going to start at 0 and count by 10s because that makes some sense to me. So if we start at 0 and then do like 10, 60, 70, Okay, that's our horizontal axis. If it had some sort of information about what it is that we were supposed to put here, like what did you measure, be sure to label that x-axis with whatever variable it is, and then again count by something that makes sense or that's normal to you. Okay, so on step 3 it says that we're going to draw some vertical lines, or you can use dots, but somehow mark on your graph those 5 numbers above that axis. And again, this is the goal of our end result of what it should look like. So if we're supposed to mark where 6 is, halfway would be 5, 6 would be a little bit past that. 10 is our Q1, so close together. 18 is our median. 31 is our Q1, and then way over here at 104 should be that max. Okay, so you're just marking above that axis where we're supposed to draw things. We're going to draw then a box around Q1 and Q3. So if we go back and think about it, there's min 1, our min and Q1 would be right here. And so we're going to draw a box around those. That's called our IQR, or interquartile range. So the IQR is representing the middle half of the data set. And then we're supposed to draw some lines out to the edges. So go all the way out to the ends, and those would be your whiskers. And it doesn't matter if you put dots there or if you put lines. But here's our box, and those are our whiskers. Okay. So now we've drawn those horizontal lines as well. And what's important for us to understand is, because they're called quartiles, like what does a quarter mean? A quarter means 1/4 or 25% of our data. So if we're looking at our chunks of how it breaks down, yesterday when we looked at empirical rule with normal distributions, we had different breakdowns. The median is breaking everything down into percents of 25. They're breaking them down into quartiles or quarters. So half of the data is in the middle here, half of the data would be below the median, half of the data is above the median, and then 25% is in each one of these spaces. Okay, so we're going to be looking at using that information on the back to find probabilities. On the back side, example 2, you're supposed to use the given box and whisker plot to identify the key features. So if we go back and look at like what is our 5-number summary, here are these numbers. There's the min, Q1, the median, Q3, and the maximum. Before we can figure out what those numbers actually are, we have to figure out what did they count by. So let's figure out the scale that they used. So if they're counting, there's 1, 2, 3, 4, 5 spaces, and they covered a distance of 10 units, 10 divided by 5 should be 2, right? So if 10 divided by, 5, should be 2. Let's count. 62, 64, 66, 68, 70, it works. So they did count by 2s. And that should help us to figure out what these numbers are. So the min is at 66. Q1, 1 space past, would be 72. The median, 80, 82, 84. 86, 88. And then our maximum, 92, 94, 96, 98. That 100 got cut off over there. So 98 is the maximum. Now we have these other ways to find the range of the data and the IQR. So the IQR was mentioned on the front page. The IQR is going from just those middle boxes. So if we go and we subtract to find the different ranges, the first overall range is the spread from the max to the min. So the maximum of our data set was 98. If we subtract off the minimum number from our data set, which was 66, we get an overall range of 32%. So this is showing us, again, like spread or standard deviation. That's a pretty wide range of scores. There's A's all the way down to D's. That's a gap of 32% from your highest test score to your lowest. For the middle part, that's our IQR. Like, where is the middle 50%? Well, the middle 50%, half the kids are between an 88% or a 72%, which would be 88 minus 72 is 16%. So most of the students are in this 16% spread. Okay. So just so we know, back when we were looking at normal distributions and we talked about the center, now we're looking at the median. Here's another way to find the middle of the data. And we also now have other ways to talk about the spread of our data, kind of like if we were to be talking about standard deviation. This is just another way to say how spread out the data is. Okay, now we're going to look at example 3. We have the age of high school students, and we're going to do kind of everything that we did on the front. The problem with this is they're not in order. So remember, the first thing that we need to do is make sure that we put these guys in order, and you need to put them in order from least to greatest. Okay. So if we look at example 3, the problem with our data that we're given on the age of the high school students is right now it's not in order. So our first task is to put them in order from least to greatest. So if you put that data set in order from lowest to highest, after you do that, then you want to find the median. So with this data set, if you're trying to find like where's the middle, since there are 10 total numbers, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, there is no middle number per se. So like the median should be like the average of those two numbers. Well, the middle between 16 and 16 would just be 16. So you'd average the two numbers together. If it was the median between 15 and 16, I'd have to say that it's 15 and a half. But since the average age between 16 and 16 is 16, our median is 16. Then we're going to look at just the lower half of the data. And again, like which number's in the middle of those, that would be 15. If we look at the upper half of the data and find the middle of those numbers, that would be our 17. And then we also need to identify the min and the max. So your min is 14 and your max is 18. So back on our worksheet, we put the numbers in order from least to greatest, and then we identified our min and our Q1, our median, and our max. We said the min was perfectly in the middle, the median was perfectly in the middle of the 16s. So we had to find the average of those numbers to be able to figure out what the middle was. And then we identified Q1 as 15. The middle of the upper half of the data was 17. Our min is 14 and our max is 18. Okay. From there we can calculate the range. The range should be the max minus the min. So 18 take away 14 would be for just 4 years, right? That's the age gap between the youngest and the oldest. The interquartile range should be Q3, take away Q1. So that's going to be 17 minus 15. So there's only a 2-year age gap between our middle 15 or 50%. To calculate the average, we have to remember that formula for average, add up all the x's and then divide by n. So if we go back and we add those numbers all together, and divide by how many people's ages that we collected. There were 10 numbers here. So if you find that total, It's 159 years divided by 10. So the average age is 15.9 years old. Okay, and we can compare that to our median age, which is 16 years old. Like all of these are in years old, right? So when we think about labeling or constructing our box and whisker plot, this time, since we do have in context what we're looking at, we're going to need to label this axis. So on our horizontal axis, our min is 14 this time, and our max is 18. We don't need to count by tens, we can just count by ones. It'll all fit nicely. And we should label years like our age of our high school students. And then if we go through and we mark those numbers, our min was 14, our max, our Q1, 18. Looks like they're all kind of nice and symmetrical. The box goes around that Q1 and Q3, and then you draw lines out to the edges for your whiskers. Okay, so here we have what we call parallel box and whisker plots. You would put them on top of each other, stacked like this. You would need a label so you can see which one's class 1, which one's class 2. This is how we compare data from two different groups or two different populations. So the first part of it says, give the 5-number summary, range, and IQR for class 1. All right, so the scale looks nice and easy for us. For class 1, we got this number here should be hopefully at 30. If you read that one off the graph, that's 75, 85, 90, and 95 would be class 1's 5-number summary. So for class 1, we have a min of 30. Q1 is 75. Your median is 85. Q3 was 90. And your max is 95. For the range, you would just need to subtract max minus min. 95 take away 30 is 65. And your IQR should be 90 take away 75, which is just 15. Can't subtract. All right, 15. On the next one, we're going to do the same thing for class 2. Class 2, if you read it, that number is over the 50, and then that number is 65, 75, 85, and 100. So if we're looking at our min should be 50. Q1 is 65. Our median mark is above the 75. Q3 is at 85, and we said the max was 100. So their range, 100 take away 50 is 50% points between the smartest and the lowest. Our IQR, middle 50%, 85 take away 65, that's 20. So we can see how more spread out or less spread out, even just from the numbers. It's nice to have the graph though. You can see class 1 is more spread out. They have more diversity in their answers. But most of the kids, right, 25%, 25%, 25%, 75% of the kids are scoring above a C plus or C at 75%. So what percent of students from class 1, oh, I just answered that, scored between a 75 and a 95? So here, that's what we're looking at right here. Like what percent is in that? Well, each one of those chunks should be 25%. So if I add 3 25s together, I should get 75%. Okay, what percent of class 1 students scored below a 75%? Well, even though it's really, really long, that still is only a quarter of our data. So we should have 25% in between our min and our Q1. So that's also just 25%. Okay. What percent of class 2 scored below that 75%? So if we go to 75%, it's right here. How many of them are scoring below? Well, that's 2 chunks worth. So 25 plus 25 is 50. More of their students in class 2 scored below a C than in that class 1. And it says, how would you decide which class did better on the test? There's lots of ways to kind of discuss this. And right now, you don't really know enough statistics to be able to argue anything. But if you were comparing their medians, like class 1 definitely has a higher median. And so I would suggest class 1 is doing better because overall they had a higher middle. We can also look at most of their data. This one right here, that how many of them scored above a C? Like most of these students are passing, 75% of them are passing versus only half the class passing in class 2. So I would decide based on the median and what percent of students are scoring higher than a C. So since more students in class 1 scored above a 75%, I'd say class 1 did better on the test. All right.
Like, subscribe, and do your homework. And if you have any questions, put them in the comments below.